All right, good morning, everyone. Certainly good to see you all today. Should have gotten an email from me earlier today about tomorrow's class. I know it's not really relevant to database class, but we will not be meeting in person tomorrow. Just an abundance of caution with all the snow we'll be getting. So I'll be streaming to my YouTube channel. You can watch it. It's up to you. So today we'll be talking about chapter 2, which is Introduction to the Relational Model. Okay, so in this chapter, it really kind of goes through, talks about the structure of a relational database. So we'll be talking about the parts of that as it relates to the database, as well as the parts as it relates to the ERD. If you look on the schedule, you'll see I'm pretty sure that I have 2 days for the next chapter. Okay, so next week is nothing but ERDs if I'm not mistaken. Is that right? So, today we're introducing the concept of relational modeling, but we're going to do a lot more examples and really just go through and make sure we're all in a good spot when it comes to relational databases, specifically the entity relationship diagram. We'll also be talking about database schema. So we've talked about those a little bit last chapter. Go into just a little bit more detail. We're talking about keys, primary keys, foreign keys, composite keys. Many different types of keys. Those are the main ones, though. Schema design. So it's going to be a very important topic when you're talking about relational modeling. Okay, schema design is how we actually achieve that. Talk about relational query language and just a little bit with relational algebra. Okay, this is not an algebra class. Okay. You don't ever really have to know much about relational algebra to be an excellent database administrator. So if you read the book in chapter 2.6, you might have been going through that and thinking this is pretty complicated. Okay, it is. To be honest with you, it's nothing I would ever test over. Of course, we don't even really have tests in this class, do we? Okay, so we have the exit exam, of course, but that's really cumulative from all the intro classes. I don't think it's major specific. I don't believe so. So it's going to be over all the intro classes. We'll talk about that more, have a little bit of review. But go ahead and start thinking back to those classes. Because like I say, I want you all to do well, and I think that you all should want to do well also. Because, let's face it, the big part of accreditation is your performance on that. In fact, that's probably the only part that you directly really do much with. So, if we lose accreditation, which we won't, okay, just making sure that we are on the same page. But that would certainly be a bad thing, right? Okay, so it's a good thing to be at a AACSB accredited business school. All right, structure of relational databases. So the idea behind a relational database is that the data is organized into tables. And in general, we think of these tables as being nouns. Okay? So if you think back to your English classes you had in high school and maybe before that, what's a noun? That's exactly right. Okay? Same thing with a table. It's a person, place, or a thing. I think they might have added a few like object and other stuff, but just think about it as a person, place, or thing. So a very common table we may have is literally the person table, right? Okay, so if we have a person table, we're going to come back to that and say what sort of entities or what sort of attributes it may have associated with the person. Okay, so the relation comes in by having multiple tables. And with these multiple tables, there's going to be some relation between them. Okay, sometimes it's a recursive relationship. We'll talk about that in the coming weeks. Sometimes the relationship may be one-to-one, one-to-many. Okay, you guys have taken systems analysis. You guys have probably done a lot of this. But the idea is that on one side of that relationship, we have to have a foreign key. Now, the foreign key's purpose is to identify each and every instance of that relationship. So we have person up here. Like I said, we're going to fill this in as we go. What other sort of entity do you think may relate to person? So name would be probably just inside of the person entity as opposed to being a separate entity. How about if we did registration? So we have a registration entity. People are taking classes. Okay. So one person has one-to-many registrations, right? Because, most of you in here, I don't know, probably all, but certainly the majority are taking more than one class. Okay, well, actually, I know for a fact all of you are taking more than one class, because you have me for another class. So we know that there has to be many, and if you're a person, we're going to assume you have to take at least one class. But a registration is going to belong to one and only one person, right? Okay? So the idea is that on one side of the relationship, there has to be a foreign key to uniquely identify each and every instance of it. So with that in mind, are we going to be able to put it on the side with a many relationship? So if I said person has many registrations, am I going to be able to come over here and put registration as a key? Why not? Yeah, because it's not going to be an atomic field. Okay, when we talk about atomic, what we're referring to is the idea that one attribute has one and only one value associated with it. Okay? So instead, obviously we're going to put it on the side with the one and only one. So we know that registration belongs to one and only one person. So we come over here. We're going to put like person ID, something like that. Okay? That's true for everything in database. That's the reason we cannot do a many-to-many relationship, because you have to have a foreign key present on one side. Okay, does that make sense? Like I say, next week we're doing examples. Actually, let's see. Today's Tuesday, right? So it's not next week. It's Thursday and Tuesday. So the next two classes. We'll be doing examples of this. But I just want to kind of get you guys in that mindset of thinking about, what all this means. Why do we have the rules that we have in relational data modeling? Okay, are they just there for fun? Or are they there so we have a robust database that we can easily use? Okay. Hopefully it's the latter. So talked about linking them with foreign key, talked about atomic. Null value. Null value, of course, is a missing value. It's not necessarily a zero. Okay, even in a numeric value, something is missing does not necessarily mean it is zero. So a lot of times it may, though. That's where you have to be kind of tricky, because it depends on a lot of things. So let's say we had a financial data set. Okay, and let's say that we had price, and let's say that we had earnings. And we have that for every single firm in our data set. Okay, but half of the firms have a missing PE ratio, so price to earnings ratio. Does that mean that all those are zero? Does that imply that? No, it does not. Okay, it implies that it's not calculated for some reason on half of them. Now, what can we do in that situation? Could we calculate the PE ratio with the data we have? Yeah, absolutely. Okay, so that's a case where you can solve null values with calculation. Okay, so basic calculations are certainly one way to resolve null values. Another way would be imputation. Okay, so with imputation, what you would do is instead of having a calculated field, maybe you're missing, let's say you're missing earnings. But a lot of stuff can predict earnings with a pretty decent amount of certainty, right? Okay, so you're not going to be able to do it 100%, but let's say that you have, say, profitability. Okay, and you know how profitable the company is. Okay, then with that information, could you give a really good estimate of revenue? Yeah, absolutely. So imputation's an option. What else could we do? Could we leave it null? Sure. Okay, so leaving it null, that may be a good option. Let's say it's a customer address. Okay, and we need to have all of our customers' addresses. Can we contact the customer? Sure. Will that be a very cost-effective way to do it? Probably not, but it's possible. Okay, so those are just some of the common ways to address null values. It's very important that we address null values because failing to address them means what? Does it mean we have a complete database? No, it means we're missing stuff. Maybe we need it. So that's why it's important to address it. All right, so some terms to know. Like I say, hopefully this is a review, but I'm going to come into this assuming you have no knowledge of anything related to databases. So a table, we talked about that. That's going to be the noun. Okay, so in a database, it's just like when you're using Excel. Okay, a worksheet is a table. Okay, it's comprised of rows. Okay, the rows, of course, are going to be the instances of that table. So it's going to be our records, in other words. So if I have a person table, and I have information about one specific person, what is that an example of? One of these things up here. What is that an example of? It's a row. It's exactly right. Okay? And then probably more importantly than that, we have columns. Okay, columns are going to be the attributes. They're going to be what we actually are interested in about each entity. Okay? So think about person. Okay, we have already established that person ID. We're going to use that as a primary key. We're going to talk more about keys as we go. Okay, what else maybe we want to know about person? Okay, so when we say name, we want to be a little bit careful. That's a great option. But think about atomicity, atomicity. We want to make sure it's atomic. Okay, not quite sure how to pronounce the ITY version of that. So what does that mean is that we're not having multi-valued sort of responses inside of a column. So what might we do to mitigate that? First name, so we're going to call that F name. Let's get MI too for middle initial. Why not L name? Okay. So what else maybe we want to know about a person? Phone number. Got to get those digits, okay? What else? Okay, so it's exactly right. We'll make sure it's atomic. So we're going to get add 1, add 2. Some people, for some reason, get address line 3. Okay, personally, I'm not even sure what the third line of an address is. Okay, I understand the street name and number. I understand apartment number. What is the third? I mean, it's like, I guess if you want to do like attention someone, you know, like whenever you do ATTN. You guys know what I'm talking about? So that's like if you have a shared mail. I guess that's what it's for. I think it's kind of silly and redundant. Okay, so I don't put it in there. All right, what else do we need for address? City. We need to have state. And zip, right? Okay. So, let's say this is a student database. Does that change anything? Is there anything else we need, I should say? So, email, username, whatever. We'll call it email. Student ID number. We'll just use person ID probably. Major. I could see that being in here. It's an important thing. Okay, it's tax season. Okay, probably not anyone's favorite season unless you're an accountant. And even then you probably don't like it because you're putting in, 12-hour days. All right, what does the college send out at this time of year? Send out a 1098-T, right? What do you need for a 1098-T? Starts with an S. Social Security number is exactly right. Okay. Now, obviously, we want to make sure we have secured database. We'll talk about that in this class as well as security. Okay, but for now, just understand that it's going to be unavoidable sometimes to collect a social. Does that make sense? What are some other institutions that may need to have a social? Certainly work. They're sending out 1040s, or it's 1040, right? Pretty sure. Not an accountant. All right, so certainly work. What else? Certainly anything medical related. I would agree with that because billing, insurance, all that stuff. Financial institutions, that's another big one. Because we have stuff like Sarbanes-Oxley. We have stuff like, RICO. Okay, you guys know RICO, right? Not a person, obviously. It's racketeering. Money laundering legislation. Okay, all that sort of stuff, they need your social. No, you can have your own opinion, and you can certainly think that's baloney. Okay, but understand it's factual, and that's what the current regulations say. I'm not stating an opinion and saying those are good regulations or bad regulations. I'm just saying they exist. Does that make sense? Anything else we can think of that may need a social? I think those are the main ones. So anyway, all of these are going to be our columns whenever we're making a table. Okay, because the idea is we're going to get the output. And it's going to be organized like this. So we start off with person ID. Then we have fname, mi. And I think you get the point. Okay? So whenever we do a basic select statement, which we'll be doing a couple weeks from now, if we just ran something like select star from, this is called person, so we're going to say person. If we just run that, we're going to get something that looks like this in the output. Obviously, we'd have all of our variables and all of our rows there. Okay, does that make sense? All right, so relation. We've talked about relation. It's going to be what connects the two. So there's different types of cardinality and stuff. I think we're going to cover that next class. But in general, we know that we can have several important things. Okay, we can have 0. We can have 1. We can have n, where we basically just use the 1 symbol and put an n. We substitute that for whatever integer we want to have as the minimum or maximum. And of course, we can have the crow's foot, right? That's many. All right, is everyone on the same page? Like I said, we're going to do more of this the next 2 classes. Okay, so primary key, foreign key, and composite key. Basically, the primary key is what uniquely identifies each instance of the table. Okay, so in other words, what we're saying is person ID must be unique. We can't have the same person in the person table because person ID is the primary key. Okay. Now, let's say hypothetically that we want to collect the same information, but we want to have multiple phone numbers. And for whatever reason, we wanted to make phone number part of the primary key. So that forms a composite key. Okay. Now what we can do is we can have the same person in here multiple times as long as they have multiple phone numbers. Now, obviously, is that the best way to collect multiple phone numbers? No, definitely not. Okay, why not? Yeah, it's certainly going to, you're basically having the same person. So when you're tying in a registration, that's going to be a lot more challenging to do. You're just making everything a lot more complicated. How can we address that in a better way? Okay, if we want to get multiple phone numbers, could we get home number? Okay, most of us probably don't have home telephones anymore. Okay, I certainly don't, but some people do. So we could certainly have instead of saying phone number, you could call it home number, work number, cell number. Okay, maybe we want to collect burner number. I don't know. You get the idea, though. Okay, that's going to be a better way to do things. All right. So, ERDs use a little bit different terminology. Okay, so an ERD, we basically call the table an entity. Okay, so it's basically the same thing. Okay, it's still going to be a noun. It's going to be what we're collecting. Instead of columns, we call them attributes about. Okay, so all these up here, these are all attributes. Person would be an entity. Okay, over here, these are all columns, right? Does everyone understand the difference? Like I say, this is the actual output we'd receive from SQL using something like this. Okay, but this is what we would actually model is an entity relationship diagram. Okay, so instead of having rows, we have instances. Instances are going to be an occurrence of an entity. So it'd be an actual person. Start off with person ID number 1. Okay, obviously, you're talking about number 1, you're talking about me, right? Okay. I don't see too many people agreeing. That's okay. So you have first name, Andrew, Miller, all my information there. Okay, that's an instance of person. Now, in a database, what would that be an example of? A row. That's exactly right. Okay? Does everyone understand how these terms relate? I hesitate to say entity and table are the same, okay, because technically they're not the same. But in practice, can you think about them as being the same? Yeah, absolutely. Okay, so when you're talking about ERD, you have entities, you have attributes, and you have instances. When you're talking about a database, you have table, you have column, you have rows. Okay, everything else is the same. Well, I won't say everything, but the other primary terms you're going to be using are the same. So you still have relations. Okay, the relations don't change. Okay, you still have primary and foreign keys. In fact, that's where you express them. Okay, so right now, I was kind of lazy. I just used the asterisk. A better symbol we could use would be like PK to denote a primary key and FK to denote a foreign key. Okay, that's going to be a lot easier to understand than an asterisk. Okay, because also, think about an asterisk, that's a wildcard in SQL, right? So when we're talking about wildcard, that means, in this context, that this is going to select everything. So, it's a little bit confusing to have it here. I think you can make that argument, okay? And of course, composite key is still going to be a primary key composed of more than one attribute. So right now, we have a composite key formed by person ID and phone number. If I were to be a little bit sneaky and erase this, do we have a composite key anymore? Why not? It's formed with a single attribute. All right, by the way, something important to know, person ID is still an attribute, even though it's a primary key. Okay? So it's also an attribute. Now over here, it's probably going to be part of the primary key if we were to, make the entire registration table. Okay, but it's also an attribute. Does that make sense? Because think about it. If we had a database, that's still going to be a column, right? All right. So database schema. Okay, database schema is going to relate to a logical design of the database. It's not an actual database. It's the design of it. Okay, so you think about the different parts of it, that's what it is. It's not the actual contents. When we start talking about the actual contents of a database, that gets more related to database instance. So database instance, of course, being some sort of a temporary snapshot of the database. So in the context of a lot of databases, we're going to be changing contents very rapidly, are we not? Okay, inserting new transactions, maybe removing existing transactions. That's unlikely. In fact, you could probably get in some legal trouble for removing existing transactions, right? Okay. Now, how would you address that in bookkeeping? Let's say you wanted to, I don't know, let's say you billed someone you didn't mean to. Do you just delete the transaction, or do you do another transaction to counter that transaction? Okay, certainly you would not just delete a transaction, you would instead, issue a sort of countering transaction. It's been a while since I've had accounting. You guys probably know the terminology there better than I do. Okay? But that's the idea here. Okay, so the schema, it's like a blueprint to a house. Okay, if I gave you a blueprint to a house, am I giving you a house? No, I'm giving you the design to make a house, right? All right, that sounds a lot more like me. Okay, do you think I'm going to be generous enough to give you an entire house? Probably not. I might give you a schema. I'm not going to give you an instance of a database. Although with a database, I probably would give you the whole database, right? Okay, it'd be kind of silly of me to withhold contents. So when you think about it in terms of economic scarcity. You guys familiar with scarcity? So what is scarcity? Limited supply. Okay, there's a limited supply of almost everything on Earth, right? The exception is digital distribution. Okay, so digital distribution, if I have a file on my computer and I upload it to wherever, okay, and someone downloads it, I still have access to that original file, do I not? Okay, so they have a copy. Okay, and the idea is that while there's technically a limited amount of space in terms of storage space that we have currently, that's, realistically, think about this in practical terms, there's no real limit to how many copies we can have of something, right? So if I have a database and I say this is a good database, I'm going to give it to all of you. I still have access to the database. Okay? It's not like I have to give it to you on a CD or something, or a floppy drive. How about that? Okay? So we don't have to worry about it. So scarcity, not really much of a factor for digital distribution specifically. Another cool thing about digital distribution, getting off topic a little bit here. You guys ever heard someone call themselves a supply chain manager? Okay. I don't think that there are very many supply chain managers. Okay, because you think about a supply chain. It begins at tier 3 suppliers in most cases. It ends at the customer. For some reason, a lot of people call that consumer. Okay, but ultimately, a consumer is not necessarily the person purchasing a product. Okay, so when we think about a supply chain, supplier, tier 3 supplier, tier 2 supplier, then the supplier, then the manufacturer. Okay, then it goes to some sort of distributor / wholesaler, then a retailer, then a customer. Okay, is there really anyone who manages that entire thing? Is there? I'd say unlikely. 2 cases in which that would happen. Okay, command economy. So that's going to be centrally controlled, aka communism. Okay, and digital distribution. So when Apple publishes their applications, specifically ones you pay for, like Logic and Final Cut Pro, okay, they pretty much control that entire supply chain, do they not? Because they're the manufacturer. They are then going out and selling it directly to the consumer. That's one of the few cases in which that can actually be a supply chain manager. But would that really be called a supply chain manager? They'd probably call it some sort of other position. Maybe director of digital services. Maybe director of software development. Who knows? Does that make sense? Kind of getting off topic a little bit. But it's important to do. Okay? So that's talking about database schema. Okay, talking about keys. Okay, we have primary keys. And it's pretty much implied in almost every implementation of SQL that we're going to have primary key constraints. Okay, those primary key constraints are going to do things like, number one, ensure the value is not null. And number two, it's also going to ensure the value does not repeat within the table it originates. So like I say, right now, we only have person ID listed as the primary key for person. That means that within this table, we have to have a person ID in every row, right? And it also means that person ID cannot repeat inside the person table. Okay, those are the two things we're talking about there. All right, we have foreign keys. So foreign key constraint is going to be related to the fact that it must be present in the table it originates from. So for instance, we have person ID and registration table right here. When we're talking about that, we know it's a foreign key, right? So it references this guy over here. And we can't have person ID 2 unless person ID 2 is inside the person table. Does that make sense? So another term you'll hear for that is referential integrity. All right. You got your composite key. The book calls it super key. I'll be honest with you, I've never heard that term in my life. So if I were to do an exam in here, I would probably list them like that, where it's either or. Because for me, I've always heard it composite key. So a composite key, of course, being a primary key composed of two or more attributes. Okay, or I guess also a composite key composed of two or more columns. All right. So you got your candidate key. That's something that could be unique. So up here, social security number certainly could be unique to a person, right? A lot of books like to argue that SSNs aren't unique, and they cite like 2 examples. Like, we got what, 350 million people? Yeah, 2 examples of a repeating SSN. I'll take those odds, okay? Would anyone else take those odds? 1 out of 175 million. Okay, so basically, what you're betting against is having 2 people with the same SSN. It's incredibly rare. Now, that said, I'm not saying SSN is a good primary key. I think there's a lot of security reasons why it's not. But to say it's not a composite key because of literally two instances out of 350 million, I find that to be a bit absurd, okay? So the chances you're going to have those 2 people in your database, actually I guess it'd be technically 4 people, would it not? Because 2 instances of it, which would imply that it's repeating for 4 people. Okay. Chance you're going to have those 4 people in your database, pretty low, right? Not impossibly low, but pretty low. So that's what we're talking about. We're talking about a candidate key, something that could uniquely identify each row in a table or each instance in an entity. All right, any questions so far? Okay, schema diagram. This is basically just an ERD without all the rules of an ERD. We're never going to do these in class because why not just go the extra tiny little bit of work and make it a full ERD, okay? So what is this missing? What are some things we don't have here? Cardinality. We don't have min and max on anything. Honestly, I'm not even quite sure what these arrows mean, okay? Does anyone know what the arrows mean? I guess. I really don't know. I think it's having to do with some sort of foreign key stuff. I didn't look at that carefully. All right? But the idea here is we're showing the relationships, just not the cardinality. What else are we not showing very well? So we have the primary keys are underlined, right? And I think that is for the foreign keys, those arrows. Yeah, I think that's what they're for. But that's not the best way to show things, is it? So it's certainly better to use, these little prefix PK and FK. Does that make sense? Because when you look at this, I don't know about you, it makes me kind of bummed out to look at this stuff. Okay, why does it make me bummed out? a lot going on. It's very difficult to read. Okay, we don't need to have 4 arrows pointing to these things. Better way to do it: have 1 arrow between section and teaches, right? Or not even an arrow. Just have a relationship. Put the cardinality on it. You get more information. You get it simpler. Okay, so I would never have you do anything like this. Does that make sense? We're going to do ERDs in here. All right, so talk about relational query language a little bit. So the primary idea here is a query language. It's going to be something that runs queries. What I mean by query, of course, is going to be a statement to return whatever we tell it to. So up here, we have a query, select star from person. Okay, so when we run that, what do we get? We get everything in the person table. We get every column and we get every row, right? That's an example of a query. All right, then you start getting into some more advanced topics, which again, not a huge focus here, but the idea is that you can actually sequence the query operation. Okay, so if you wanted to have different queries take place at different times, or really about the order, then you would use, of course, it's called imperative query language. And the idea behind doing that is, let's say you wanted to do calculated fields. Okay, so obviously you would do, you would obviously do the calculated field first, and then you do the operations based on the calculated field. That's the sort of thing we're talking about here in this context. So go back to the price to earnings ratio example. Let's say we had price and earnings information, but we didn't have PE ratio. Could we sequence our queries such that we first create that column and store the information in it, and then could we do stuff with the PE ratio? Is that possible? Yeah, so you'd use imperative query language to do that. Okay? And that's implying you're actually storing the variable. You don't always have to. So we're going to talk about casting in this class. So casting, of course, would be using the as modifier. Okay, that's going to be getting more into functional query language, where we're not necessarily concerned with storing it. We're concerned with developing it for use within the query, and then after that, it not sticking around. Does that make sense? All right. And then lastly, you have declarative query language. And basically, that's where you don't specify the order and the system specifies it for you. Based on a bunch of algorithms and stuff, no need to worry about it. It's going to happen automatically. So any questions about these? Like I said, a lot of this stuff happens behind the scenes. You don't have to be so concerned with memorizing every little detail here. Okay? You think you're going to go to a job interview and they're going to ask you about an imperative query language? Probably not. Even for a DBA position, they probably would not. You think they're going to ask you about left join, outer join, and all those? Yeah, probably. Okay, I got several friends who've done interviews for various DBA positions. They're asked about stuff relating to, the queries themselves. Okay, they're not asked what is it, in an academic definition. Does that make sense? Can you apply it? Okay, joins are going to be a huge topic. In the 223 section, I only really go into inner joins because it's the default. But in this class, yeah, we're going to be doing left join, right join, inner, outer, full, every type of join. Does that make sense? All right. So relational algebra. Again, this is not something we're going to spend a lot of time on because, quite frankly, can you be a database administrator and not know any of these terms? Is that possible? Well, other than select, that's probably an important one, right? Okay, but the idea behind relational algebra is how could we write our queries without SQL? Okay, so am I ever going to have you do this in class? No. Why not? You almost certainly wouldn't do it in a job unless your job is mathematics PhD, okay? Which I don't think that applies to many people in here. All right, but the idea here is simple. So we have the operations we want to do. We want to figure out how can we denote them mathematically. That's what this is all about. So you got your unary operation. Okay, so the unary, as you can tell from the prefix un, is going to be for one relation. So maybe it's recursive. That's certainly an option. Maybe you're just looking at a single person, whatever. Okay, binary, it's going to be the bulk of what we do in here. So binary is going to be relating to two relations. And of course, you can go beyond that as well. A lot of times you'll be doing different queries based on far more than two relations, right? Okay, I certainly think we'll run into that as we go throughout the semester. Okay, so select, that's basically going to be where you're going to be able to return fields. So like I said, you have select star, that's selecting everything from the person table. That's an example of select relational algebra. All right, and you got Cartesian product operation. Basically, it's where you're taking information from two or more relations, and you're combining it. Okay, so the product is multiplied. But don't think of it in terms of multiplied as in any sort of mathematical multiplication. Okay? Just taking information, combining it. Okay, you got project. So instead of just taking everything like you do from Cartesian, the difference here is that you're selecting particular columns that you want. So instead of doing select star, that would be similar to doing select, say, person ID, F name, and then maybe person ID from over here. Does that make sense? Okay, and then join. Like I said, we're going to talk a lot about join in a couple weeks from now. But the idea here is that we specify some condition. And we do that, of course, with the on operator and the equals operator. All right? So those two things are going to allow us, in SQL at least, to be able to grab whatever information we want from the two tables, or two or more tables. Because a lot of times, we may do joins, and we may have 3 or 4 in a single select statement, right? Okay. So that's pretty much what we're covering. Like I said, next class we're going to pick up with a lot of examples and go through this in a lot more detail with ERD specifically. But today just kind of introduces the structural components of the ERD and all of that stuff. So make sure you bring some pen and paper with you next class, or use whatever online tool you want for an ERD. I think Paul was telling me about something you guys used in his class. What was that tool called again? Draw.io. We'll probably use that together, I guess. So bring pen and paper if you want. But that's pretty much wrapping everything up. Any questions? All right, stay safe in the snow. We'll see you all Thursday. Remember, no security class. Well, it's online only, so I'll just be streaming to my YouTube channel.